I'm Anil Kumar, and now it is time to review what we have learned about the primary trigonometric ratios. When I say primary, I mean sine, cosine, and tangent, right? You know SOHCAHTOA. So we will review in this particular video how to use which type of ratio to solve a right triangle. Now, before getting there, I'll share with you some of the most popular questions which always come again and again, and you will find them in your test papers also. So this is probably these are the most popular ones in this sheet. I always see every year students solving and asking for help. So here are a few triangles which you can copy the questions. So pause the video, copy these questions, try to solve them. The idea is that I will take a few examples which will help you to solve these questions. I'm not going to give you solutions of these particular questions, right? So these are a few more. So what you can do is you can just pause the video, copy these questions, and then try to solve them, right? So these are few more, correct? They may not be very clear, but anyway, I will take some of them. Now in this sheet, we also have application questions, right? So these are the most popular application questions. So I'm going to solve them also one by one. I might provide you with complete solutions for most of the questions, right? So these are some more application questions. So there are about 12 application questions, and after going through these 12 application questions, I will reveal the most difficult and extremely important examples which you should know to get full marks in trigonometry. Now let us begin with the basic rules, that is learning about sine, cosine, and tangent and how to use them. On this particular sheet you see four triangles, correct? Now that is the right angle, you can see, and opposite side to right angle is the hypotenuse. And whenever we are referring to an angle, then angle and right angle forms adjacent side. Side opposite to the angle given is being referred to as opposite, right? Not the hypotenuse. At times I've seen that kind of confusion also. Now let's begin by answering our basic question, when to use which ratio. That is the first and the very important question which we need to understand how to resolve, right? So basically we always talk about three ratios. One is sine. So in general, let me use angle theta for us. So sine theta. Now this time I wrote sine with capital S. Strictly speaking, S has to be lowercase. So all trigonometric ratios should be written by lowercase, okay? So there is a correction, I'm making it right there. S is small, okay? Now whenever we say sine theta, then we use SOHCAHTOA. SOHCAHTOA really means it is a ratio of two sides opposite over hypotenuse. So I'm writing in short form, opposite over hypotenuse. That is what sine theta is. But when we talk about cosine, then in that case cos theta, please note this is lowercase c, right? Cos theta is adjacent over hypotenuse. So adjacent side is the side between the angle and the right angle. Opposite side is side opposite to the angle referred to. So if theta is here, like in this case, if theta is here, then opposite side is 7 and adjacent side is 3. Since 90 degrees and theta, they form adjacent side. Okay, so adjacent over hypotenuse. Now in this triangle, hypotenuse is unknown, right? Okay, now tan theta is what? Lowercase. Tan theta is opposite over adjacent, right? So opposite over adjacent. Now I've seen in grade 10 especially, most of the students write all trigonometric ratios with capital letters, which is not a very good practice. So adopt lowercase. Look into your book carefully and see how they write, okay? Now you know these three ratios. These are called primary trigonometric ratios. So SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tan is opposite over adjacent. Whenever you begin solving questions about trigonometry, write it on the top, SOHCAHTOA, right? And then begin working Now let us solve triangles. When I say solve triangles, it means what? That is also important to understand. So when I say solve triangle, let's write down solve triangle. It means what? It means find all sides. It means what? Find all side lengths, right? And angles. That is what it means. Whatever is not given in the diagram, find everything, right? So that is the meaning of solve triangle. Now when I say find all trigonometric ratios, that means find sine theta, cosine theta and tan theta for every angle, okay, in a particular triangle. That is what it means. Now, we'll not get into a lot of details, but we'll touch upon most critical parts, right? So we have four triangles and we need to solve these triangles. Let us say that is our basic question. How to solve these triangles? And that will answer this particular question, when to use which ratio. So the question for us is solve triangles, right? So that is the question. And these are the triangles given to us. So let's begin from the very first triangle. Let's say this is our triangle A. Now in this triangle, what is given to us? This is what you have to figure out, okay? So think about SOHCAHTOA and see what is given to us. So what we are given here is, reference is always the angle and this 90 degrees. So this angle is theta for us, and what we are given, if you are looking from theta point of view, right? So we are given this side, which is opposite, right? This is opposite side. And from theta, this is adjacent side, right? So what we are given here is a combination of opposite and adjacent. So which trigonometric ratio fits in? Opposite and adjacent, it is tan, right? So it is tan. I'm writing T here capital, right? Tan ratio. Do you understand? So tan theta should be used to solve this particular triangle. That is what the key is. So what we can do here is, we can write here tan theta equals to, opposite. So I'm not writing opposite over adjacent. Well, let me write here. Okay, opposite over adjacent, just to remember all this, right? Opposite side is 7, but this is something which goes in your mind, okay? 3. So we know tan theta is 7 over 3, and that helps to solve this particular triangle. And whenever tan theta is something, then what is theta? Theta is tan inverse, right? Theta is tan inverse over tan inverse 7 over 3. Then use your calculator and then say shift tan inverse within bracket 7 divided by 3 bracket close equals to, and you get 66.80 as your answer, right? So which is 66.80 in degrees. So you get your angle, which in this case is 66.80. You have to be careful. They will normally tell you how many decimal places you need. So maximum go to 1 decimal place as far as the angles are concerned, or round them if not mentioned, okay? So once you know this angle, this triangle is more or less solved using trigonometry, right? Okay, let's move on to the next one. Take it as a practice. Now you tell me, which trigonometric ratio should I apply here to solve this second question? Okay, this is part B now for us. So we are given a triangle here. We are given one angle alpha, right? 5 and 12 are the two sides. That is the right triangle. Which ratio should we use? Now look at it like this. This angle is 90 degrees and this is alpha, and this side should be adjacent side. Is that okay? And here we are given hypotenuse. Do you see? Opposite to 90 degrees is always hypotenuse. So we have an angle, and with reference to this angle, we know adjacent and hypotenuse, and therefore the ratio should be cos, correct? Adjacent and hypotenuse. So that is the role of SOHCAHTOA. Easy way to remember, correct? So in this particular case, we could write cos of alpha. See, the angle is alpha, okay? So we'll write cos of alpha is equal to adjacent over hypotenuse, right? You don't have to write adjacent hypotenuse, but write the side, which is 5, over hypotenuse, which is 12, and you can solve for the angle. Say alpha is equals to cos inverse of 5 over 12, correct? Again, use your calculator and say shift cos inverse, and 5 divided by 12 is 65.37. So we get alpha as 65.37, right, degrees. Okay. Now, you should not be dividing 5 by 12 and writing some decimal value here. If you do that, then your angle will not be very accurate. In case you want accuracy, you have to write 4 decimal places for this ratio, right? So remember that part also. You have to write 4 decimal places to get an accurate answer. If you write less than 4 decimal places, you're not going to get accurate answer, okay? Now in this case, if you have to round to whole number, then you will write this as 65 degrees approximately, right? So that is kind of the work which is required to be done to solve such a triangle. Now let's continue and let's take up the next triangle, which in our case is the right triangle with 65 degrees given to us, and one side is given, the other side we need to find. So in the previous 2 triangles we found that the angles were given to us, and like we were trying to find the angle, right? In these cases the angles are given to us, okay, but we have to find the side. So whenever we are solving trigonometric ratios, I should say the right triangles, using trigonometric ratios, we will be either given the angle, or we need to find an angle, or we need to find a side, okay? So that is the case. Now in this particular right triangle, let me know which trigonometric ratio should we apply to solve this particular triangle. So we'll again look at it from the angle point of view, which is 65 degrees, opposite side, right? So this side is opposite, is it okay? And this side is adjacent. Do you see that? Opposite and adjacent is the combination here for tan, correct? So we are going to use tangent ratio, is that okay? So we'll write tan of 65 equals to, opposite side is y, and then 4, right? So always this is how we have to do it. Now to solve a ratio, cross multiply. To solve any ratio, just cross multiply. So y is equals to 4 times tan of 65. Or you may say multiply by 4 both sides, so you'll cancel 4 on this side, you're left with y, okay. Now, so y is equals to 4 times tan of 65 degrees. Use calculator, find the answer. So we have 4 times tan 65 equals to 8.578, right? At times you may be required to round it to 1 decimal place. Let me round to 1 decimal place, 8.6. Well, in this particular exercise, what we will do is, we'll round them to 1 decimal place, all the sides, okay? Now once you know that, then you know what the unknown side y is, and you have solved the question, right? So let's move on to the next one now. Now that's the question for you once again. In this particular triangle, which trigonometric ratio should be used so that you can find d? Okay, now what are you given? You are given the angle 32, opposite side is 5. So when you look from here, right, so this is opposite, do you see that? And this is hypotenuse. If you know the combination which you are dealing with is opposite and hypotenuse, then it is sine. Do you see that? So that is how you could use trigonometric ratios and solve right triangles. I hope the concept is absolutely clear. If not, I'm giving you a link, and then we'll have some more practice questions, right? So sine of the given angle, which is 32 degrees, is equals to opposite over hypotenuse. We have written this right on the top of your paper. You should do it when you do trigonometry test also. But don't write opposite and hypotenuse here. Avoid that part. So the opposite is 5 and hypotenuse is d. Now from here, apply ratios and find d. Cross multiply. Let me write it down here, right? Because at times you may get confused at this stage also. Now you cross multiply to solve. So we do d comes here, right? And 5 divided by sine 32. Do you see that? Sine 32 degrees. Use calculator. Next step. So you do 5 divided by sine of 32 degrees, okay? Now, calculator at times could be in radians, so ensure that it is in degrees. So we get 9.435. Now, as a practice, we are just rounding to one decimal place. So we'll write this as 9.4. Perfect. So that is how you have to solve your triangle. Now, one more word of caution. At times, we might give you units. I mean, if I write meters here, right? In that case, you have to write meters in your answer. You get my point. So in case there are units given to you, you have to write units. Otherwise, you lose a lot of marks. If I write this in centimeters, for example, then your answer will be in centimeters. Perfect. So when the sides are concerned, look for the units. It is not necessary that the units will be there, but sometimes you may find units in the question. Include them in your answer, right? And write clear answer that the side length this is that much. I hope with this you're ready to explore more about trigonometric ratios and their applications. And now in the following videos, we'll look into the most popular application questions, and there in every application question which I solve, we'll first make a decision which trigonometric ratio should we use and then solve it. That will really give you good foundation for solving problems using trigonometric ratios, especially when we're talking about right triangles. I hope that helps. I'm Anil Kumar. Subscribe to my videos and learn a lot. Thank you and all the best.